So this is a walk around of the Obsidian version 4 USB power delivery development system. So it looks much like the version 3 with a couple of different features on it. So first of all, working from the bottom left here, we have the Opal Kelly 6001 development board, of which we use a number of features. This system can be used standalone for basic testing, and it can also be used connected to a host. So in standalone mode we have various jumpers that we can use. The main two are one that selects provider or consumer, and then we have a couple of other jumpers that select which settings we negotiate for if we're a consumer. We have a reset switch and something which controls the swap. It's on another switch, and we have some LEDs here. All of these four blink when it's in normal ready mode and communicating. That's transmit activity, squelch, receive activity, and so on. And the bottom two show which power option is actually enabled within the system, and usually represents the PDO that's currently in use. So at the other end of the Opal Kelly board we have our USB connector, which will go to a Windows host, and it can be used for a number of things. For example, it can be used just for powering, and the system will operate just for signaling purposes off the 5-volt power of a host. That's sometimes convenient. And we have a switch which chooses between full standalone operation or operation from the host. And when we operate out of the host, we have several applications that we can use. There's a streaming state information that tells you the current state of the policy layer for the system, and also various other things like logic analyzer and so on, rather protocol analyzer for the PD packets themselves. And most of the rest of the board here is power supply, except for the OTC9102, which is the physical layer or analog front end for PD here. We've got a few headers, 3 actually, for picking up different frequently used signals on a scope, just for monitoring purposes or logic analyzer. Here's the PD inductor. It's a 6 amp inductor, so it's quite a big one here. And then we have a number of USB connectors here. The first one is for connection to a PC or connection to a peripheral. It's an AB connector, and so it can be used either way around. And so it could be connected to a PC, which by the way also can power the board, and it can also be connected to a peripheral like the logic connection to a disk drive, for example, and be powered appropriately to do that if it's a consumer end that we're talking about. It only has 5 volts on its V-bus, and so it can talk safely to those kinds of objects. And then we have a standard APD connector here, and another AB connector which is in parallel with it, and this is used for chaining in the protocol analysis mode of the board. We also have some terminals for power output, and these are used in conjunction with the other terminals to provide power to the consumer end of the board when it's set up. So the logic connection would come out on the PC connection, and the power would come out on these terminals, and that allows you to simulate a wide variety of different actual settings for PD. A couple of different switching power supplies here, and an external power port. This is, I believe, a standard 5.5 to 2.1 millimeter. It uses a positive tip, by the way, important to know, and it typically can be connected to any universal laptop power supply which generally come with a set of switches that you can choose between 15 and up to 24 volts. This unit will only work up to 20 because of the limitations of some of the power supply components on here. This is a linear regulator used to provide 3.3 volts for the Opel Kelly card, and this card is basically powered from whatever power is available. 3 or 4 different ways, one from its own host interface, another one from a PC interface here, or from the PD voltage itself, if that's usable, or from the external power. So it's a very flexible power arrangement on the board, and there are a number of power diodes here that make sure that that all works smoothly and automatically together. So there we have it. There's the V4 development board from Obsidian.